Hello everyone, welcome to the online learning series. Today's discussion is on the topic of projectile motion. So today we are going to solve some numericals on projectile motion. Let us first write down the formulas which are required for solving the problems. First case is when I have a person who is standing on a cliff or a mountain or a tower. Let me consider a person who is standing on a cliff, mountain or a tower, and it throws an object with some initial velocity v0. So the person is throwing some object who is standing above the ground, a height of this, let me consider it as h distance above the ground, and it throws some object which is thrown at an initial velocity v0. Then what happens to this object? The object will move in the horizontal direction because of the horizontal velocity given by the man, and it starts to fall down because of the gravitational force which is acting on it. So here you can see the object has been traced a path which is parabolic. If you have been asked problem on this case, then the time of light will be given by the formula 2h by g, and the horizontal range is given by the formula v0 x into t, or you can write this as v0 x under root 2h by g. In case of horizontal projectile, when the problem is on horizontal projectile, the time of light and the horizontal range are being given here. Time of light is under root 2h by g, and the horizontal range is v0 x into t, or it can be written as v0 x under root 2h by g. Second case is when a person standing on the ground throws an object with certain initial velocity obliquely. So the person is throwing an object and making the angular projection. So this is angular projection. This we have studied in our session 6, that whenever an initial velocity v0 is being applied on an object, then the object gets projected into the space and it moves vertically for some distance and then it comes down. As the projectile goes up, the vertical component of the velocity decreases and becomes 0 at the highest point, and as the projectile comes down, the vertical component of the velocity increases, and finally the object or the projectile reaches the ground. And what about the horizontal component? The horizontal component will remain the same throughout, as there is no horizontal force acting on the projectile. We have also derived the time of light, horizontal range and maximum height for this case. So let us first write down all those formulas. Now we have these formulas for horizontal projectile. The time of light is under root 2h by g, and the horizontal range is v0 x into time of light t. For angular projection, we are going to take the time of light as equal to 2 v0 sin theta by g, and maximum height is equal to v0 square sin square theta by 2g, and the horizontal range is given by the formula v0 square sin 2 theta by g. Here v0 is the initial velocity with which the projectile will be projected into the space, and g is the acceleration due to gravity, whose value is 9.8 meter per second square, and theta is the angle of projection. Let us now solve the problems. Coming to the first problem, it says that a hiker stands on the edge of a cliff 490 meter above the ground and throws a stone horizontally with an initial speed of 15 meter per second. Neglecting air resistance, find the time taken by the stone to reach the ground and the speed with which it hits the ground. Take g is equal to 9.8 meter per second square. Now there is a cliff on which a person is standing and projecting a stone, and this cliff is of 490 meter height. It is given, its height is 490 meter, and the person will throw a stone with some horizontal velocity which is given as 15 meter per second. Next, what happens to the stone? The stone will move in the horizontal direction because we have given some velocity in the horizontal direction. Then the stone will come down to the ground because of the gravitational force which is acting on the stone in the vertical direction. You have to find out the time taken by the stone to reach the ground and also the speed with which the stone comes and hits the ground. These are the things which you have to find out. They say that G is 9.8 meter per second square. So what case is this? Is it a horizontal projectile or a angular projectile? It's a horizontal projectile. Therefore, we are going to take up the formula T is equal to under root 2h by G. So this is equal to under root. To find the time of light, I am going to take 2 into h. H is the height, that is 490 divided by G is 9.8. This is 2 into 490 by 9.8. This is 9.8 ones are 50s are. So 50 into 2 is 100, or you can write this as 10 seconds. So the time taken by the stone to reach the ground is 10 seconds. Next, we have to find out the speed at which the stone hits the ground. For that, we are going to take up the x component first. Vx is equal to v naught x plus ax t. So this is equal to v naught x is what? It is 15. So this is the horizontal component of the velocity because it is projected in the horizontal direction. Therefore, this is v naught x which is equal to 15 plus what is ax? There is no acceleration in the horizontal direction. Therefore, this will become 0. This is 15 meter per second Vx. Similarly, let us find out Vy. Vy is v naught y plus ay into t, and that is equal to v naught y is 0 because at this point there is no v naught y, there is no vertical component of the velocity because the projectile is projected in the horizontal direction. Therefore, v naught y will be 0 minus g ay, that acceleration due to gravity is taken negative, minus g into the time. Therefore, this is minus 9.8 into the time which is 10. This will be minus 98 meter per second. Now we have the Vx and Vy component. I need to find the speed. The magnitude is found by using the formula V is equal to under root Vx square plus Vy square. That is equal to under root Vx square is 15 square plus Vy square is 98 whole square. Even though I have negative here, when I square it, it becomes positive, and that is equal to, I am going to get 99.14 meter per second. So this is the speed of the stone with which it hits the ground. Let's move on to the second problem. A particle is fired horizontally with a velocity of 100 meter per second from the top of a hill which is 500 meter high. Find the time taken to reach the ground and the distance of the target from the hill, and also find the velocity with which the projectile hits the ground. They recommend that to take g as equal to 10 meter per second square. So g is said to be taken as 10 meter per second square, and the height is 500 meter, and the initial velocity v naught x is 100 meter per second. These are the things which has been given. So from the top of the hill, a particle has been projected with some initial velocity, that horizontal initial velocity. Therefore, it is v naught x which is equal to 100 meter per second, and the height of this hill is also given which is 500 meter. Now we have to find the time taken by the particle to come down to the ground. Therefore, as given, the formula is T is equal to under root 2h by G, or this is equal to under root 2 into h is 500 by G is 10. So this will be under root 100, which is nothing but 10 seconds. So the time is 10 seconds. Now we have to find out the velocity with which the particle comes down to the ground. Therefore, let us find out the x component of the velocity first, which is v naught x plus axt, but here ax is equal to 0. Therefore, this term becomes equal to 0. Then Vx is nothing but V naught x, that is 100 meter per second. Similarly, let us find out Vy, which is equal to V naught y plus Ay t. Now this is equal to V naught y is 0. There is no vertical component of velocity, minus g into the time t. Therefore, this is minus 10 into what is t? It is 10 second. Then Vy will be equal to minus 100 meter per second. Next, to find the velocity, the magnitude of the velocity is given by the formula Vx square plus Vy square, which is equal to 100 square plus 100 square, which I can write it as 100 root 2 meter per second. This is the magnitude. Then coming to the direction, let me take tan theta is equal to Vy by Vx. Then that is equal to 100 by 100, which is equal to 1, or theta will be equal to tan inverse of 1 is nothing but 45 degrees. Moving on to the third problem, a cricket ball is thrown at a speed of 28 meter per second in a direction 30 degree above the horizontal. Calculate the maximum height, the time of flight, and the distance from the thrower to the point where the ball returns to the same level. They have given the initial velocity as equal to 28 meter per second and the angle of projection 30 degree. You have to find the maximum height, time of flight, and the horizontal range. Let us take down one by one. What type of projection is this? It is an angular projection. A cricket ball is thrown with this velocity 28 meter per second at an angle of 30 degree from the horizontal. That is, so if this is the horizontal, a cricket ball is being thrown in this direction with making an angle 30 degree. Therefore, this is an angular projection. Therefore, we are going to use these formulas here. Let us first find out the time of flight. Time of flight is given by the formula 2 V naught sin theta by g. Substitute 2 into V naught is 28 into sin theta is sin 30 degree divided by g is 9.8. This is 2 into 28 into sin 30 is 1 by 2 divided by 9.8. This 2 and this 2 gets cancelled. We have 28 by 9.8, which is equal to 2.857 second. Next, let us find out the maximum height. The maximum height is given by the formula V naught square sin square theta by 2g. So, this is equal to 28 square into sin square 30 degree divided by 2 into 9.8, which is equal to 28 square into sin 30 is 1 by 2, whole square is 1 by 4, and that is divided by 2 into 9.8. So, this gives me 10 meter. The maximum height reached by the object is 10 meter. Coming to the horizontal range, it is given by the formula V naught square sin 2 theta by g. V naught square is 28 square sin 2 theta. Theta is 30 degree into 2 is 60 degree divided by 9.8. So, 28 square into sin 60 is root 3 by 2 into 9.8. Let us find out its value. So, its value will be 69.28 meter. So, this is the horizontal range. Moving on to the fourth problem. A bullet fired at an angle of 15 degree with the horizontal hits the ground 3 km away. Can we hit a target at a distance of 7 km by adjusting its angle of projection? In this problem, they say that the bullet is fired at an angle of 15 degree and the range of the bullet is taken as 3 kilometer. Now they are asking, if I change the angle of projection, can the bullet reach a range of 7 kilometer? What is the formula for range? It is given by V naught square sine 2 theta by G. What is the maximum range formula? Maximum range is V naught square by G. That is because sine 2 theta should become equal to 1. When is sine 2 theta equal to 1? When theta becomes equal to 45 degrees, sine 2 theta becomes equal to 1, and this is the maximum range reached by any projectile. Now using this formula, I am going to write the R is already given, which is 3 kilometer. That is equal to, we don't know what is V naught square, sine 2 into 15 degree divided by G. And this 3 kilometer will be equal to V naught square by G into sine 30 degree, which is 1 by 2. Or I can write V naught square by G as equal to 6 kilometer. What is this V naught square by G? It is nothing but the range which is maximum. Therefore, R max is equal to 6 kilometer. So, even though if I change the angle of projection, the maximum range reached by this bullet is only 6 kilometer. But in the question they have given, is it possible for the bullet to reach a range of 7 kilometer? It is beyond this range, the maximum range. Therefore, it is not possible. The bullet cannot reach a range of 7 kilometer. It cannot go beyond this range, which is 6 kilometer, because the maximum range which the bullet can reach is 6 kilometer. Now, I will read out the fifth problem. Calculate the maximum horizontal distance travelled by a ball thrown with a velocity of 40 meter per second without hitting the ceiling of an auditorium of height 25 meter. The question says that a ball is thrown inside an auditorium with the initial velocity 40 meter per second. What is the horizontal range of this ball? The maximum horizontal range of this ball that can be reached without hitting the ceiling of this auditorium. The ceiling of the auditorium is at a height of 25 meter. So, the ball which has been thrown should not touch the ceiling of the auditorium. Then what range, the maximum range it can reach without touching the ceiling of the auditorium? First, let us use the formula of maximum height, which is given by the formula V naught square sine square theta by 2g. Here V naught has been given, which is 40 meter per second. So, 40 square sine square theta by 2 into, let me take this as 9.8. And HM is also been given, which is 25. The auditorium height is like 25 meters. Now, let me find out what is sine theta here. So, from this, sine square theta is equal to 25 into 2 into 9.8 divided by 40 square. That is equal to, this is 0.3063 and this is sine square theta, but I want sine theta. So, let me find out what is sine theta by just removing the square root. So, if I remove the square root for this value, I am going to get 0.5534. This is sine theta. What is the formula for range? Range is V naught square sine 2 theta by g. I know V naught square and g. If I find out theta, I can easily find out r. Or I can also write this formula as 2 sine theta cos theta by g. Now we have found the value of sine theta. If I find out what is the value of cos theta, then easily I can substitute here. So let me find out what is cos theta. Cos theta is given by the formula 1 minus under root 1 minus sine square theta, or this is equal to 1 minus sine square theta is 0.3063, which gives me the value of cos theta. 1 minus 0.3063. 3063 and remove the root, you will get 0.8329. This is the value of cos theta. Let us make the substitution and find the horizontal range. Now this is equal to V naught is 40 square into 2 into sin theta is 0.5534 into cos theta is 0.8329 whole divided by 9.8, and this is equal to 150.5 meter. This is the maximum range the ball can reach. So 150.5 meter is the maximum range attained by the ball. Moving on to the last problem. How much high above the ground a boy can throw the ball if he is able to throw the same ball up to maximum horizontal distance of 50 meter. So they have given the maximum horizontal range. Now we have to find the maximum height attained by that ball. Maximum horizontal range is given by the formula R max is equal to V naught square by G, or I can write V naught square by G is equal to 50 meter. To find the maximum height, let us use the formula V square is equal to V naught square minus 2GHM. Now at the highest point, the velocity, the final velocity is taken to be 0. Therefore this will be equal to V naught square minus 2GHM. If I rearrange this formula, I am going to get this as V naught square is equal to 2GHM, or HM, which I have to find, will be equal to V naught square by 2G. But V naught square by G is already known to us, which is 50 meter. Therefore HM will be equal to 50 meter by 2, that is 25 meter. Ball can attain a maximum height of 25 meter when the horizontal range, which is 50 meter, is already been given. These are the 5 marks problems on projectile motion which will be asked in the examination. So I am going to end the session here. In the next session we are going to study about the uniform circular motion. Thank you.